All right, we've just had Starship IFT-10. That was a massive success. I am partial. I'm going to give it an almost perfect 10. And I think a lot of others watching the launch of the SpaceX Starship would tend to agree. I've got an expert panel with me today to discuss not only IFT-10, but a lot of the spin-off programs that we could expect over the next 5 and 10 years from SpaceX. I've got Aaron Burnett. He's the founder and CEO of Mark 33, and Vlad Chago. Also with me is Gustav Anderson. He's a hand surgeon and associate professor of anatomy in northern Sweden. And then we'll have Scott Walter, of course, who's a mechanical aerospace engineer, two-time founder of robotics companies. He'll be joining us shortly. So really looking forward to this discussion with all of you guys, gentlemen. Thank you so much, first of all, for joining me. Let's discuss IFT-10. Start off with you, Aaron, and Vlad. Your takeaways. It was quite the show, wasn't it?
Yeah, thanks for having us. Yeah, I think it was a success, probably beyond expectations, mainly because of the fact that we'd had kind of 3 not so great launches prior to that. I know my breath was held for all the way until I think orbital insertion, their version of orbital insertion for this test. Yeah, I think it was very good and pretty much success across the board. A couple interesting things on maybe the heat tiles. We were discussing this a couple days ago. What exactly was that? What did it mean? Was it small, big? No one really knows until you get a real update from SpaceX. The demo for V3 Starlink satellites, I think, is probably the thing I've been most interested in ever since, ever since they first were going to try it. So that was big for me. I'll pass over to Vlad on kind of his.
Yeah, it was a comeback this launch, because they had 3 launches where people started doubting whether the plan was going to pan out, and they nailed all the milestones. Yeah, there were a few hiccups along the way, as there always are with these test launches. They're pushing the rocket to the max, so they can collect the best data. But I think I agree with Aaron. I think the biggest achievement of this launch was the deployment of the Mach V3 satellites, because those are by far the satellites are by far the biggest valuation driver over the next 5 years. They are so much more performant than the current generation satellites that it'll unlock so much cash flow for SpaceX to achieve the dream, which is scaling Starship to the point where we could go to Mars. That was always Elon's mission, and without those V3s being deployed, that was never going to happen. So seeing that happen, I think it was a relief for me, because they tried before and it didn't work out. Even the door, the payload bay door, wouldn't open. I'm not particularly worried about the ship landing kind of orange. For any of you that watched it, it went up half black, half stainless steel, and it came down orange.
Do you think Donald Trump had anything to do with that?
Yeah, I'm sure there was some fake tan going on up there. No, my sentiment has shifted, and I'm sure everyone's sentiment has shifted after that one.
So the whole heat shield aspect, that is one of the main problems. It feels like that is left. Sadly, they can't collect it now and have a look at it. But even if you, looking at your models, if you would remove Starship out of the equation after deploying the satellites, how important is it to have the rapid reusability of the Starship section? You have the booster coming back and might be shut up again, but the Starship itself, will you still have a decent win if you
yeah, that's a good question, because we actually just released an analysis on this week. So what's interesting is that those V3 satellites are so much more performant that Starship could be completely expendable, like rockets have been so far, and they would still be cheaper than launching with Falcon 9 on a cost per kilogram basis. But the thing is, it's just the fact that they can even fit on it. So this rocket is so big that they can fit much larger satellites, the V3 satellites, and those benefit from physics scaling laws, and that's where that extra performance comes from relative to the V2 minis. So they could launch them with fully expendable Starships for 5 years. Yeah, hell, they could not figure out the heat shield till the 2030s, and that would not have a massive impact on Starlink financials. So for me, it was the fact that the rocket got up there, it didn't blow up along the way, and they were able to release the satellites. That is the most important thing for an investor in SpaceX right now.
Yeah, and for all of you who are watching and interested in the how Vlad and Aaron have crunched the numbers to bring out the report that I just pulled up on screen, I'll leave a link down below in the description. Do go through that because it's fascinating, and we're going to do a more detailed breakdown of that. But we're short on time because we've got Gustav for a very little time with us today, and I want to rush through it. Scott, quickly, your big takeaways. Give us your 35,000-foot view of everything that happened and how it went down.
I think it was a 160-kilometer view, actually. No, just go quickly to the orange. I mean, there are a lot of theories. One theory I heard is might just be kind of exotic plasma physics chemistry, that they had a couple of heat tiles up there that may have had like copper or something like that in it. And basically what you were seeing is plasma deposition. And it all kind of fanned out that way. But going back to the big thing that we haven't talked about was what happened to the skirt and what went on there. And now one theory is that it may have been actually one of the dummy satellites. And I don't think so for a couple reasons. But one thing I want to talk about is that I think Scott Manley said that they were actually ejecting them out in the orbital direction, which kind of surprised me. That why would you put it in the orbital direction? I think you'd want to be retrograde, be kicking them out so that you wouldn't have this possibility of impacting. But even then, if their relative velocities are nearly the same, they're almost zero. So I don't see that if it was to hit one of those things, I don't think it would do it with that amount of energy unless you were in some sort of a reentry phase where one of them was like suddenly slowing down a lot. Because remember, these things are light. So if you threw it out in front, and suddenly it was slowing down a lot and you're coming in there. So you were in a slightly reentry phase. But do you know for sure, Vlad? I would have assumed that they were kicking them out behind them because you want them to reenter anyway. So by kicking out behind them, you're going to give them a little bit of retrograde and they're going to slow down.
Yeah, I don't know for sure. That was a surprise to me as well. I would be surprised if it was the mock satellite. I mean, I haven't looked into the theories. Do you have any other theories for why the skirt went?
No. It was energetic. So it's like there must have been something that combusted or exploded. Now, if you had fuel there, you would also need to have oxygen. And so it's like, where's your oxidizer coming from? So are there two leaks? Was there something that was getting very hot and then was like an oxygen leak, and then the oxygen just allowed that to kind of, rapidly ignite or do something? But I'm not really sure, but because that was fairly energetic and rather quick and didn't look to me like someone bumping into something else. You don't get a flash.
Yeah, you're right.
Something like that.
We'll find out shortly, won't we?
Yes, we will.
Release a report probably later today or tomorrow.
The main thing is it was robust. Yeah. I mean, took a licking and kept going.
I think that was the intention, really, wasn't it? Because they kept reminding us that they were pushing the ship much beyond its limits.
I feel like I'm the guy in the meme in the party standing in the corner with his thoughts thinking, man, SpaceX just solved our trip to Mars and these people don't even realize it. I mean, it was really exciting to see them succeed to this extent, I think.
Right. All right. So let's discuss this other report that you guys at Mark 33 had brought out on the Starship reducing bandwidth launch cost by up to 50x. Phenomenal numbers. Do you want to take us through this and how IFT-10 success is really changing the game?
I can kind of do the introduction here. Vlad did a really cool analysis here that I was pretty excited when I was reading it and kind of working on it as well. It's kind of obvious when people think about Starship, or maybe I think it's obvious and not everyone feels that way, but Starship is reducing launch costs dramatically. Something that most people don't appreciate is even if it was fully expendable, which Vlad hinted at this earlier, it drops launch costs dramatically by itself. I think we're estimating somewhere in the neighborhood of like $700 per kilogram. Not that they would charge that, but just the size of this thing really allows for a lot of payload going to orbit. This is, and when we say that, we're talking about, you know, the V3s, V4s kind of payload sizes that they're targeting. And so it's very substantial. This is kind of what everyone's expected. But what you get is you get some cool effects when you start combining the advantages of V3 Starlink satellites, which are bigger. They can pack more punch, more power, and therefore more bandwidth per satellite through. So you combine that advantage plus the Starship advantage, and those stacked advantages they really start to change things as far as the dollar per gigabit per second, which is a metric that I don't know that anyone else uses it. Glad that I'm not sure. It's not that like it's a thing that we totally invented, but we're definitely talk about it, and I don't think many people really talk about it. It just is a very helpful way of framing the idea of, you know, the cost of a piece of bandwidth, if you will.
Well, on this chart up here, you see the gray curve is Falcon 9, and then the other curves are different reusability variations of Starship. Either the red ones, whether they're fully expended, the purple is whether the booster is reused, and the green one is if the whole ship is reused. And what you see is when you look at it from the point of view of just launching any kilogram to space, Starship is roughly an order of magnitude at 20 reuses. Starship is roughly an order of magnitude cheaper because the whole rocket is reusable. Maybe 5 times cheaper. And then what happens is not only is Starship fully reusable, which is part of the reason that the cost goes down here, but it's also bigger. And because it's bigger, you can launch bigger space assets on it, larger satellites. And in the same way that rockets that are bigger benefit from physics scaling laws, that means the cost of getting to space, the mass, the propellant ratio is improved. The satellites themselves, when they're larger, there are physics scaling laws that mean that you can deliver more bandwidth for the same mass of satellite. And so then what happens is if you layer those on top of each other, then the numbers get really crazy. So I don't know if you have that second chart. Well, yeah, actually, this is perfect. Let's see the V3 mock V3 plates, whatever they are, being deployed. So this was the moment where
just quick clarification, Scott. This gas, the movement of this gas that we see as it gets sucked out, that's the time when the payload doors opened, right?
Yeah. That was really neat. So something happened that they did a little venting that it cooled down, and you've got condensation in there from the remaining atmosphere. So you literally had a cloud, and then as soon as I saw that go out, it's like, okay, it's open. But I think they had to do a little bit of purge ahead of time
to kind of give viewers a visual.
I don't know, but that was cool for sure.
Yeah. Right, Vlad, sorry.
No, all good. What I was basically getting at is that once you layer the scaling benefits of larger satellites on top of the scaling benefits of bigger rockets, then you get a multiplier that the numbers go crazy. So rather than just an order of magnitude increase in efficiency, launching bandwidth on a per kilogram basis via Starship is 50 times roughly more efficient than doing it with Falcon 9, so the older, smaller rocket. One thing to bear in mind is that when I ran that calculation, I didn't include the cost of manufacturing the satellites because I wanted to isolate the benefit of the launch vehicle. If you include the cost of manufacturing the satellites, that 50x becomes a 10x, and that's because adding even the same amount of manufacturing cost, it just shrinks that gap. So that's the first chart. I'm not sure if you have the second one. Notice the difference between the lines here, and then if you scroll down to the other chart, the difference between the lines is a lot more massive, and that's what I'm trying to get at. That is the multiplicative effect of larger satellites on a larger rocket. And that was fascinating for me to figure out, because that shows that we're at the very early innings of this constellation, and it's going to accelerate in the rate at which it's scaling, for one, and that's going to drive a lot of benefits for end users. So not only more capacity and so as a result high quality of service, but prices will go down. I mean, 50x or 10 to 50x improvement in cost, that will be reflected in prices. There's no way that it won't. So that was a big takeaway for me as well.
Yeah, that's phenomenal. I mean, because that has a direct impact on your TAM, isn't it?
Yeah, well, how much of the TAM you can fill, for sure.
Yeah,
Yeah.
and also think about the redundancy you're getting rid of, because every satellite
Mm.
has to have a minimum amount of avionics and navigation systems, everything that has to be there. And the whole point is to get as much surface area up in orbit to be able to relay all this stuff. So if I need 5 satellites to do that versus 1, well, wait a minute, I only need to have 1 of the avionics and I can just kind of scale that. So already you're seeing you don't need to have all this duplication of components. That could also drive your manufacturing down, because you're not really literally having to build 5 satellites. You're only having to build 1.
Mm-hmm.
Because there's this interesting post on X from the VP of, this is Michael Nichols. He's the VP of Starlink engineering at SpaceX. Says a Starlink mini laser shown in today's video will connect third-party satellites and space stations into the Starlink constellation. The mini laser is designed to achieve link speeds of 25 Gbps at a distance of up to 4,000 kilometers, and was recently successfully tested in orbit on a satellite launched on Starlink G10-20. Wow,
that is interesting. That's like the interlaser links they already have, but for third parties.
What do they call it? Plug and placer? I think
that's a great name. I didn't know that.
Yeah.
Yeah. They heard it, but I guess I'm a little bit surprised seeing this, because this looks more like a telescope, which is trying to point in a particular direction. Whereas I thought the laser links they had before were using like these internal rotating prisms to be able to direct it. Now I wonder if this is just more kind of a macro pointing, and then maybe the micro is in somewhere else, because that's going to take a while to be able to move around. And the other thing that's a challenge is that when you're doing something like that in space, you're reorienting the entire satellite by doing that. So you need gyros that are kind of countering that at the same time to make sure the rest of your kit is still pointing in the direction that you want. So there's a lot of interesting engineering challenges that I just wanted to point out.
From the market perspective, what's interesting about this, I forget when they announced this concept of, last year or something, where they're going to be doing these laser terminals. The cost of getting data, like if you have a satellite today, down from orbit can be up to $1 million per satellite per year. It's actually a pretty significant cost. It's kind of one of those, idiot index things that that Elon likes to target. So while it's not as massive of a market as the broadband market, which is what they're talking about, it is a massive enabler if you can get into the Starlink network for downlink. They have all these, downlink terminals all over the planet, and effectively they're now saying, hey, anyone else that's using your, whatever satellite constellation you have, you actually can get your stuff back to Earth much faster and cheaper. And that's actually a pretty significant enabler for this, 100,000 satellites out on, off planet kind of thing that people are expecting to happen. But so far to date has pretty much
100,000 Starlink in the constellation.
No, just Starlink in general. I think the space industry is expecting I think the bull estimate is 100,000 satellites by 2030, just in general around the globe, and that is the bullish estimate, and maybe 30% of that Starlink. I mean, to date, Starlink is basically all the satellites, not all, but
I think it's 8,000,
70% of them.
It's about 2/3. That's about 8,000 satellites in the Starlink constellation.
So once that network shell is kind of there, and there'll be others, Kuiper will be a competitor to this as well, because that's a decent, $1 million per satellite per year. There's a lot of cost to be, cut out of there. So if you can start to build those shells and have some competitive shells in the existing networks that exist today, there's others that are targeting this.
And let's not forget the Chinese. Do you think SpaceX will open this up to this feature up to the Chinese constellations, or is there going to be national security issues involved?
I don't know if the Chinese would want.
And this is not Starship.
Open themselves up to it.
Starship is a whole different kettle of fish.
No, I think it doesn't make sense to me, because they could, never say never, but China's trying to build their own Starlink, right? So they would probably be trying to, replicate a similar kind of thing, not only for bandwidth on Earth, but again, then you have a network that any satellite anywhere can connect into and get all of your data down much faster. And like part of the problem that exists with that, it's costly, but if the revisits and where you can get down, like and how much bandwidth you can get down, it's something like a 10x or 100x. There's some big number of the amount of data that is generated on satellites that actually gets sent down. So there's a lot more information and data that we could be pulling down if you had constant communication. So that point being with the China question, they're going to have the same problem. This is just like Earth, the way Earth works, the way geometry is, and where you have the ability to downlink your data is fairly limited, and they'll have the same problem.
Okay, let's quickly take a look at this report from you guys: fiber versus Starlink, cost versus capacity. Have you factored in direct to cell into this at all, into your calculations, or is it just home based with the receivers?
So this is purely broadband. On the direct to cell thing, we actually we're almost done with our model. So I'm saying it's like 95% done. So we can have another session to discuss the outcome of the direct to cell model.
Whenever it's ready, you know where to come.
Yeah, I know. And this one's purely broadband though. So we wanted to compare what basically the cost of Starlink or satellite broadband, but in this case study Starlink, versus providing broadband via fiber. I can give you the two main takeaways. There's two main takeaways. So I think what's important to know is that right now, Starlink is cheaper on a per kilometer basis to provide a kilometer with bandwidth, because of just the economics of launching satellites that are always orbiting and always providing service wherever they are, versus digging a massive tunnel or building towers to draw fiber. So when we ran the numbers, we made a little model, and currently today the cost of providing Starlink bandwidth versus fiber bandwidth crossover at 150 premises or houses per kilometer squared. So right now today it's 150 at 150 houses per kilometer squared. That's kind of where the costs are about even. Now, once you project the constellation capacity out to 2030,
quick clarification: is this for the existing version of satellites, or is this for the next gen?
That is Starlink today. So that is Starlink today. Now, which I'm going to get to, is that Starlink can't provide enough capacity for 150 houses per kilometer squared. The cost equals out at 150 houses per kilometer squared, but they can't provide that. They can provide, on average, about 5 to 10 houses per kilometer squared. That's how much capacity they have up there. Now, that is an average. They can point the beams. So technically, in certain areas, the number could be higher per kilometer squared at the expense of other areas where there would be none. But on an average, it's about 10. Now, by 2030, when you run the same model with the constellation in 2030, the cost crossover point between fiber and Starlink broadband goes up to 800 houses per kilometer squared. So that's where the cost evens out. And the capacity saturation goes up to about 100 premises per kilometer squared. So that means, while today they can only really on average provide broadband to 10 houses per kilometer squared, in 2030 they'll be able to do that for 100. So thinking about the impact of that, the main one is that right now Starlink is renowned for being used rurally, right? It's like rural internet. And that line where you draw now, where you're like, oh yeah, this area is good for Starlink, everything else needs fiber, that's going to move closer into the city by 2030. Fiber will still be dominant 100% in city metros. I mean, in somewhere like Manhattan, there are tens of thousands of houses.
For how long will it be dominant? Is this a forever?
I think forever. I think it's just like a physics thing. There's so much more potential capacity from fiber than from having a satellite beaming down broadband, that in dense urban areas, it will just never really be possible for a satellite to...
I'm curious, how is it going to compare when you stack each one up against the other when it comes to speed? Because you've got last mile connectivity issues with copper wiring, etc. Not all complexes, I mean, the newer complexes have fiber pre-installed, so you get a higher speed. But then for older areas, you've got still last mile connectivity issues with copper and stuff. So
no, that's a good question. So Starlink is better than copper right now, but fiber can deliver up to 1 gigabit per second, roughly. Let's say, like my connection here in the city is 1 gigabit per second.
Yeah,
fiber.
Same.
With Starlink right now, it's a little bit higher, but let's say it's 100 megabits per second today. That 800 premises number I gave you in terms of the crossover, that's a 500 megabit per second plan. So I already kind of took that into account into the numbers that the speed's going to increase, because Elon has told us that the speed is going to increase and that they'll be able to provide up to 1 gigabit per second speeds by 2030. So I brought that down a bit to average between lower and higher plans. So those kinds of speeds are unprecedented in a rural area today. That's like, I don't know what you even get out of copper, but it's significantly higher.
Yeah.
So yeah, that's another thing. Not only Starlink probably will never have the capacity to provide gigabit speeds in a city, but in general, I think speeds will lag behind fiber just by the nature of the physics of the technology.
Yeah.
That being said, what this analysis is
No, please do continue.
What this analysis shows is that Starlink's sphere of influence is going to get closer and closer to the city, and you're going to get closer to the suburbs, not just rural areas. The suburbs will be disrupted by Starlink in 2030 for sure.
But that's just one factor at play. And you have automation, and we've discussed this in the past as well. You have automation and in mobility and all of that, which means also cities will be expanding. So I guess we'll see a situation where the
a good metric to help understand that is just the number of people per square kilometer on average in any given country. And I forget World Bank or what the data source I had for that was, but
which is why
effectively the US is 32 people per kilometer square. It's a lot of land
on average,
and a lot of people, but not, there's still a lot of land per person. Whereas the UK, I think, was 100 something. And China is a little bit closer to the UK than to US, given the large population, something like that. It kind of is all over the place. But if you put it in context of what Vlad's saying with number of, how much they can support, a Starlink V3 constellation in the future can support, which is 100, 150 people per square kilometer, then effectively the vast majority, the average population, is actually within the support globally. It's just those dense urban centers that would, in theory, always be connected by these transatlantic kind of backhaul cables, but everything else, get you global coverage with V3 and maybe whatever the V4 version of Starlink is.
So just to put these in perspective, because for a lot of viewers and maybe trying to imagine how does this map to my subdivision or something like that. So I was doing some mental math here quickly. So a square kilometer is 1 kilometer this way, 1 kilometer that way, which is basically 10 football pitches this way by 10 up that way. Okay, so that means you have 100 of those that are in there. Now, a football pitch by a football pitch is technically
American football.
A hectare. It's a hectare. Okay, so if you ever want to know what a hectare is, it's 100 meters by 100 meters. Okay, so that means we have 100 hectares in there. Now, people don't think about hectares in the U.S. They think about acres, and it's basically 4 acres in a hectare. So that's about 400 acres. So just imagine in the exurbs, you're talking about people have houses that might be like an acre or bigger. So you can support 400 1-acre homes. If you get more into a subdivision, they tend to be a 1/4 acre to maybe a 1/2 acre if you're lucky. So you got to multiply that by a factor of 4. So still in there, you've got about what is that going to be 1,600 homes that you could pack in there, not thinking about roadways and everything else, but that's about what you are. So we're about 1/10 of the way there. If it's 150 right now and we need to get up to 1,600, That's about where it is. Doesn't mean everyone's going to be using Starlink, because I'm happily using Starlink right here, and I'm also in kind of a thickly settled area, but not all my neighbors are using it. I think I have like 2 or 3 Starlink neighbors, and that's about it. But it turns out to be a heck of a lot better than the fiber I have here, because the fiber I have here is like really sensitive to rain and tides and like seems like everything else. So there are definitely areas where you find that it is a more reliable service over what is even the existing infrastructure that supposedly is fiber.
Yeah. Okay.
Yeah.
I know,
fundamentally, V3 is going to think of it as it's going to be able to serve suburban everything. Like it will definitely be an option. Will it be the only option? And 1,000 people all using it right next to you? No, but pretty much every suburban area, you're going to have the ability to use it, and it'll probably, in theory, they might even be cost competitive.
Okay, I know you guys have a hard out time, but I quickly want to squeeze in a quick clarification. So when you're talking about this crossover between Starlink and fiber, which year is this? 2030, and what sort of cadence are you looking at? Have you based your calculation on? Because if you have a Starship mature earlier, that could affect the timeline, wouldn't it?
Yeah. So that was a 2030, the larger number, where I said that the cost crosses over at 800 premises by 2030. And you're right that the timelines could be sooner or slower. The way we got to those numbers were we did a Monte Carlo model with ARC, and in that model we inputted all the ranges of possible timelines for Starship. So one end of the range was Starship starts launching V3 in 2026, and the pessimistic end was it would take till 2028 for them to start launching V3s. And so that Monte Carlo model basically ran simulations and then statistically calculated the average most likely constellation size in 2030. So that's like based on where we were at 2-3 months ago, that's statistically the most likely constellation size in 2030. I'll be honest that with the last couple of Starship launches and the blow up on the pad, I thought we'd be more on the pessimistic side of things. And now, because of the launch this week, my confidence is renewed that model is right. So I'm gonna stand strong by that 2020. It's 20,000 terabits per second by 2030.
All right.
That's the number we have.
All right. Well, we'll have to leave it at that for the moment. But thank you so much, Aaron, Vlad, Scott, and Gustav. Thank you all, gentlemen, for joining me. And we're going to pick this up next time with some more details.
Yes, sir. Thank you.